Thank you. It's a great honor to be here, though I guess you were all expecting FX to be here talking to you, right? Um, yeah. The thing is, he got seriously sick at short notice, caught himself quite the sinus infection, and it's so bad that he's not fit to fly. So at short notice, you have to deal with me, the stunt double. But, well, long story short, I'm actually one of the guys who's building what FX was planning to talk to you about, so I guess I can give you the quick intro here as well. But before I get started and delve into the presentation proper, let's take a step back and think a bit about the trust infrastructure and applications that every one of us is using on a daily basis. A few weeks ago, we were visiting a company. It was quite big, multinational, and when we were in the office of the IT sec guy talking to him, I glanced over his shelf, and there was this one item. It was a grappling hook, I kid you not, complete with, I think, 5 meters of rope attached to it. And he caught my glance, and he was like smiling at me and said, well, that's our trust anchor. And the not so funny thing is that I think he was only half joking. So what kind of trust systems are we using today? Are they hierarchical? Are they mesh-based? How fine granularly can you decide who to trust with what? How fast can you react to changes in that trust? Do you have to use explicit revocation? Or does it just happen automatically? And how good do these systems hold up against attack? Think if you're having a hierarchical system and you cut the head off, do you have chickens running around without a head, doing whatever chickens without a head do, or can you still operate? So I think we do have a solution for that, which I'm going to tell you about now. Pecky is FX's second company, and what we're doing is the culmination of over 10 years of research, which originally started as the ISO 28828 automotive standard. The automotive folks sat down in 2006 and decided, well, we have pretty massive distributed system, cars, and we have kind of a key distribution issue and a trust issue. So how do we fix that? And they sat down, wrote a standard, and what they called for was basically a peer-to-peer PKI. If you look closely, that's kind of where the company name comes from, but we built something that does way more than just being a peer-to-peer PKI. So we're now building something that also solves the ISO standard, but does way more. So, what is it we're building? We're building a system that lets you, each individual person, be their own trust anchor. You're no longer relying on a third party. We'll offer you a straightforward interface. There will be, in the simplest case, one single function. Can I trust entity X with a very specific formulation of trust Y? And you get one answer. It's yes or no. Also, you can use the system either entirely in offline scenarios or, the way we recommend, using a crypto-enforced peer-to-peer network. But what can you do with it? Imagine that your devices will actually trust you and you no longer need to enter a password. You could build an actual self-defending network instead of, well, what we have now. And as I said before, you no longer have to rely on a third party for trust. So, trust, what is that? In the current IT world, if you're thinking trust, you're thinking, well, trusted web shop, trusted certificate, trusted whatever, but that's not really it. Trust is not knowing. What is currently sold as trust is confidence, and confidence is a very fickle thing. Confidence very easily breaks. So confidence is basically predicting how someone will react in the future by ensuring that it will happen, by having absolute control over it or relying on a third party that has absolute control over it. And if something goes wrong, it might take a while till everyone notices. Just take DigiNotar, for example. While with trust, you're relying on future actions of someone, but only for a very, very specific amount of well-defined control that you're handing over to said entity. And the way we implemented that, if you want to, everyone can see your trust. And if something changes in that trust, everyone can see that. So you have oversight in your peer group, and with that you can react a lot quicker than, well, if someone carries out keys from DigiNotar. Well, so to sum up, trust is the middle state between knowing and not knowing. If we again take a step back and look at the classic CIA triangle, if you have confidentiality and integrity, you could use a certificate authority to give you that, but availability, if the certificate authority breaks, you're screwed. Equally, if you have encryption and signatures, you're fine as long as you have the key. If you lost your key, well, you're screwed. And let me tell you, there's a big company that set up their certificate authority the way you do it by the book. They took their root certificate key, put it on a stick, put it in a safe in one of their offices, and forgot where it was. In the end, it all comes down to cost. And cost can be many things. But not all problems you're having have to actually be authentication problems. So where can you use something like authorization? It's good enough to be authorized for, say, parking tickets, doing taxes. Well, if you have a tax counselor, you're authorizing him to do your taxes. Nobody cares who exactly he is, as long as he does his work good. But then there's also stuff that needs a little bit closer inspection, like changing configuration, or telling your anomaly detection system to please shut the fuck up while you're fixing the problem, or turning things off. And I mean by that, like cities, turning them off probably needs some closer inspection. Over here, you're very, very fine with trust, usually. Over here, you better verify. So, computers and trust. What we're doing is we're teaching computers human trust, the way humans work, with all its transitive glory. So, underneath our system, we have a transport backend. To that, there's no really little, well, we don't make huge demands. It has to be a key value store. We recommend using what we're currently using, an Ascademlia implementation for the peer-to-peer network version, but it could be easily a local database, a flat file, or even a complete offline solution. As long as it got a key value interface, you're good. On top of that, we're building the trust overlay network. The information stored there is basically, I'm trusting this entity with a very specific policy, I'm trusting that entity with a slightly different policy. Everyone publishes that signed, and you can retrieve that information and then rebuild the latest trust information every node published. In parallel to that, you can, of course, instead of just storing trust policies, store data in that network. And again, we don't care which backend you use. Together, you get trusted data. You no longer have to fetch a point of data and verify it. You tell the trust network, give me something, and you either get nothing or you get trusted data. What you get for free is situational awareness, but if you want to learn more about that, hit me up at the bar later on. On top of that, it's you and your own trust anchor. So, one specific problem of the many problems that we can address with this system is what we dubbed the device nightmare. Think device provisioning. You're a vendor of devices, and you have to get them to your customers, of which ideally you have more than one, and you want to do maintenance. And as we learned in the talk before, passwords are hard, logistics equally, so you don't want to use the same password everywhere, but, well, that's work. So what is so hard? You have basically two choices. Either you go ahead and keep a stock of customized devices per customer with all their keys on it, which might pose some other legal consequences because maybe you are not allowed to handle your customers' key information, or you keep a big, big stack of unconfigured devices, which you'll have to touch every time a new customer comes around and wants to order something, which doesn't work. And yeah. So, what are we doing different? With the human trust model, you manufacture a device, and this device initially trusts you as a vendor. And in the specific example that I'm going to show you briefly, so the demo gods will, the initial trust will be for device handover. So the company can hand over the device to some customer. Once the product has been paid, that handover is done, and a transaction of ownership should be easy enough for everyone to understand. You do that once you're paid, everything is done, good. So, let's head over to the demo. Bear with me. Where is it? Okay. Let's see how that goes. While this is booting up, I will be using the debug UI that we built specifically for this problem, because we didn't find anything that was good enough to debug a distributed trust network. So we built our own and ended up with a second product, which is worthy of its own talk at some point. But let's see how that works. There we go. So a little bit more about the scenario. I already mentioned that there is a vendor who manufactures devices, so we have two players, a vendor and a device. There's also a customer, participant 3. The customer wants to buy a device. Now, the vendor is not a trivial company, so it got a billing department and a support department. The vendor is trusting its billing department to check whether a customer has paid already or not, and if the customer paid, initiate a handover of the device to the customer. The billing department is not allowed to do maintenance. Likewise, the support department is only allowed to do maintenance and not handover. Let's start them. Let's start the vendor and its departments, start the customer, and start the device. Let's hop over here. And while we wait for them to boot up, I'm just acting like a fool. There we go. What you're seeing now is the peer-to-peer network slowly building itself. On this layer here, we have basically Ethernet communication. what you'll see in this UI is a ring surrounded by nodes. The nodes are usually either trust nodes or IP addresses, and you can display either values for that node or relationships between them. Now, not that one. Not that one either. That one here. Here, I'm the billing department, and I'm connecting to the device that was just manufactured. The device recognizes that, well, I'm being connected to from the billing department, and I don't have to enter any passwords. It also notices that I have a permission to do a device handover. If I take a look over here, this is the view the support department currently has of the device. No access at all. And if we take a look at the customer didn't pay yet. No access at all. Let's say I'm the customer, I just paid. I'm calling the billing department, tell them, well, I just sent you X amounts of money, give me the device. So the billing department says, well, hand that thing over to customer 1. The handover was complete, and immediately the billing department has no rights whatsoever over that device anymore. If we now take a look over to the customer can now write to his configuration on the device, which is basically what you want. But you also want to do maintenance, firmware update, outrolls, whatever. So as a support department, I can now do device maintenance. And if we take a look at the UI now, let it refresh. You're seeing the device down here only ever trusts up there the vendor or now the customer. There is no direct trust to the billing department or the support department. This is transitive trust. So the device initially trusts the vendor with do a handover. The vendor trusts the billing department with do a handover. Then someone that looks like a billing department, which the device doesn't know, comes along, says, well, do a handover. So you ask the trust system, using that one magic function, can I trust billing department for device handover? And you, the device, being its own trust anchor, start searching on your site. What kind of trust do I have in my local store? Well, I've got one trust that is good for handover, but that goes to vendor. So you ask vendor, what kind of trust do you have? And vendor tells you, well, I'm trusting support department with maintenance. That doesn't help you in that case. But I'm also trusting the billing department with doing handovers. Well, that's good. Now you have a path from you via vendor to the billing department. And that is all you need to do. Let's go back to the presentation. One very neat thing that we notice, how do we actually solve the problem above with identities? It turns out that identity is a subset of trust. Well, sadly, I wasn't introduced so, but usually I go by Hades. And if someone would have introduced me that way, you'd probably believe them. So having an edge from someone telling me I'm Hades and you believing that person to introduce people, you established my identity as being Hades. So everything we do all the software will be released under Apache 2.0 license. But we're doing something a very little bit different. So you won't be finding a direct download link. What we're trying to do is not gather your information. We just want to hear from you what you are planning to build. And that has one very simple reason. You send us an email, tell us, well, I have this specific problem. I want to address this using your Trinity trust system. Send me the code. And then we'll send you the code and tell you, well, go in that direction, maybe not do it that way. If you're unsure, call us and we come help. Because the worst thing that could happen is if you haven't understood X509, you're bound to reinvent it poorly. And yes, we are a consulting team. So if you have any questions, give us a call. If you have a problem, ask us and we'll come. And now I'll be open for questions for the remainder of my talk. Thank you. So what we've learned is that we build a very general system, and it's hard to get across what the system can do, and people immediately fall into a very specific set of mind and then think that's what we do, but the system does more. So if you have a specific questions, come ask now.
Hi, thanks for the presentation. Checking the website, I noticed that you offer different implementations of the system. Can you tell us a bit more about each of them? I think
yes. You're talking about Fat Boy and Little Boy? Yes. Fat Boy is what we're currently developing. We're targeting the Java JVM, which will be okay for a lot of applications. Little Boy, on the contrary, will be an implementation targeting embedded devices and will be probably written in Mizrahi.
You just gave trust to one of the components?
Yes.
How do you revoke it and who is allowed to revoke it?
You actually do not have to explicitly revoke anything. You're publishing who you're trusting right now. This can be time limited if you want it to be so. And if you fetch trust information from the network, you can store that locally and evaluate it as needed. If you get a request now and you think, well, this request is a little bit fishy, maybe I should recheck if the trust is still the same, you just query the node in question again, tell it, well, tell me all your trust that you have right now. You're not asking the node directly, you're asking the peer-to-peer network. And then if that node, that trust edge is no longer there, so isn't the trust. So you do not have to revoke, you just no longer extend that trust edge to anyone. You can also think of things like distrust, which we can also model. So you can explicitly say, well, I'm fine with that node in principle, but I'm not trusting it for alcohol recommendations, which might happen. So yeah, that can be modeled as well. Answer your question? Any more questions?
what if you have a question to the network and you happen to ask me if you trust someone that I know or whatever, and then I always say yes because I want to access your current operation. Or on the other hand, can I always say no and therefore cause denial of service?
Well, what we do is we implement human trust. That is human trust, period. So everything that works in real life, like getting cheated, will work. The thing is, as in real life, you can very easily react to that. So if someone screws you over, that happens once, and then your peers know about it, and then it doesn't work anymore, and you don't get a foot on the ground. So yes, you can behave like an asshole, but then people will know you as the asshole you are. Does that answer your question, or? Okay.
So if you bring human trust to device, I want to reinstall, reset my phone or computer. So in human terms, kill it. Will it trust me afterwards?
That is a pretty abstract question. So for this, I guess your device would have to be sentient, which it is not. So I guess I can safely answer that question for now with it'll trust you with whatever you set up. I think there was a question up here. Two, actually.
Yeah, hello. A question on this scenario of a peer sabotaging or subverting by always saying no. And you said, okay, well, if a peer misbehaves in this fashion.
Can you speak up a bit? I don't get it.
Okay. So I'm relating to this example scenario where a peer misbehaves and always answers no.
Yes.
And so attempts to subvert the system in this fashion. So, like, if that is established, like, is there some kind of rating system that would rate that peer as untrustworthy, or how do you prevent this?
Well, there's a subtle difference between a node in the trust overlay network and a node in, say, the peer-to-peer network. Nodes in the trust network publish their trust into the Kademlia peer-to-peer network. And I'm not sure if you're aware of how Kademlia works, but in the end, it's evenly distributing its key values over the network and spreading each key value out over a neighborhood of values or neighborhood of nodes. So you're never actually querying the node that originated the data. You're just querying signed data that you can verify of other nodes in the peer-to-peer network. So you'd have to be a very, very powerful attacker as to control which values are retrievable from the network. And as Kademlia specifically counters that attack, which would be, if I'm not mistaken, an eclipse attack, where you try to shade a certain key space and control which values can be retrieved there. So that can't be done.
So it sounds like you're creating that one of the implications of this is you can create almost a trust score or an integrity score of individuals. Have you looked at like how that looks if it's gamified? Like if people start trading off on trust and how that can be either manipulated or useful?
Yes, you can actually use the data that is published to, well, extract metrics, in that case, a reputation. And any system you build will be gamed. There's no arguing with that. The thing is, how can you react to it? And how would you react to that with your human peers? If you get wind of someone deliberately cheating and doing insider trading effectively at the cost of some of your other peers or yourself, you'll get pissed off, and that's where the distrust comes in. So you point fingers and tell them, well, no, you're not. There's one over there.
Still linked to the previous question. So this means that you can point finger without actually, like, because you want to take someone out of the ring, let's say, of the trusted ring. So I say that you cheated, well, while you didn't. So how the other then verify? I mean,
yes, I can.
Like it happened
Yeah,
in real life.
I can
People
point
are
fingers
screwed,
at.
and
I can
like
point
it happened in real
fingers at
life.
everyone here and tell them
Yeah,
you
and
cheated. That won't work, because actually you have to trust a node to accept its distrust. So if you're not trusting that node for at least distrust information, you're at no time evaluating that. And even if some of your peers say, well, I don't trust that one, what you do with the information you gathered in the end is always a local decision. So you can say, well, it's a case of emergency, and before drowning, I'll reach out my hand to that node, which I might not trust normally. You can do that, it's a local decision. But other than that, you'd have to trust a node for distrust, for that to work. Any more questions?
I have one more. Some of us agree that one of the biggest problems in IT or even in general is naming, and it is tightly coupled to identity management.
Mhm.
Are you enforcing any kind of naming convention on the users, or is it just up to the actual initiator of the query?
Yeah, that would actually be very scenario specific. The thing is, the system itself does not make any requirements towards names that you go by. But depending on the system you're implementing, you might want to put some restrictions in. Say, if you're replacing a domain controller in your company, you want to control the names that are in the trust system. Equally, if you're implementing something like PGP or S/MIME, you obviously need something like email addresses. But yeah, that is not affecting the system per se, but that would be a scenario-specific implementation. Any more questions? Well, if you don't want to ask, there's one over there. If you don't want to ask here, I'll be here a while, so you can catch me later on as well.
Brief question. Can an identity be cloned, and what happens in the system if that happens?
Since an identity in and of itself is basically a key pair that you usually don't get in touch with, you'd have to have access to that private key. So yes, you can clone that as long as you have a private key. And if that was a legitimate clone, well, you can do with your identity whatever you want to do. They would basically look exactly the same. So they are exactly the same because they're a clone. If you mean by that there was a compromise, someone stole your key information, then get in touch with one of your peers that you trust, and the message get out that that identity is burned. And you don't have to explicitly revoke, which is a nice thing. People can just drop their trust edge to you, and then you're good. And you don't have to wait for someone to, kill the CA or something.
Thanks.
Any more questions? Doesn't look like it. So I guess that's it for me. Thank you very much for your attention. If you have any questions, I'll be around for a while. And please remain seated for the closing ceremony.